Hello, my name's John Capobianco, and I'm a product marketing evangelist for Selector AI. And we have a really big, exciting enhancement and augmentation to our already groundbreaking and revolutionary tool, the Packet Copilot. Now, this tool lets you upload a PCAP or a PCAP NG file, and you can chat with it. It uses retrieval augmented generation, and it's anonymous and it's free. So you can interrogate, have discussions with, ask questions about, do learning, educational type questions, security questions, software development questions and code generation, visualizations in ASCII and Markdown, all multilingual, any language in the world. We've seen dozens of languages so far and hundreds of people with different packets and different scenarios. And the Packet Copilot has held up. It's really done an outstanding job, and it's making waves, and it's a tool that people are using and want to use. In fact, I will be at SharkFest in the summer talking about and demonstrating this at Wireshark Fest. Now, what's the latest enhancement? You may have heard of AI agents and how agents are going to take over the world and how agents are going to be the big thing in 2025. You've heard this from many sources in the news, in technology, word of mouth. Agents seem to be the hot new topic in AI. And they are. They're the evolution of AI using APIs, AI using RAG and retrieval systems, and now AI using agentic approaches. So what we've done is build a public IP address geolocator agent. So now, when you prompt, you still upload a PCAP and you still ask it questions. We've added some intelligence to get metadata for you in the form of the geolocation of any public IP addresses discovered in the packet. So we're going to use AI to analyze this packet and do a little bit of pre-processing. If we find public IPs, invoke the agent, hand off to the agent, gather that geolocation information, and enrich and enhance the already astounding prompt inference about this packet or packet capture. So we're going to do some of this together. It's really exciting stuff, and I think it has drastic implications, right? Where are these packets coming from? That's a question you can ask our Copilot today. What can you tell me about these packets? It will now include geolocation information automatically. You can force it and ask geo-specific questions, or your broader questions or normal questions. Like I said, it naturally will discover agentically the presence of a public AI and the requirement to reach out to the cloud and get the geolocation. So just in case this is unclear to anyone, we're going to take a quick drawing. So we have our user. And our user uploads a PCAP file with their prompt. All right, now this is the Packet Copilot, the Streamlit IO front end, and the LangChain retrieval augmented generation workflow. Now, it also is our agent router and is responsible for routing traffic to and from our new public IP geolocator React AI agent. React, and let's type this up for everybody, and let's make this extra large. Re, meaning reasoning, and let's just put chain of thought or reasoning capabilities, depending on the model you're using and its capabilities, and act for action. And this comes in the form of tool calling and the ability for this little agent here to actually run code on its own via tools to go to this weather API that you can pass an IP address, which will return a JSON payload with the geolocation. And now we're going to augment the original prompt here. Let me get the arrow again, or this. Right, so that JSON flows all the way through, and now we're able to augment, right? I'm going to say geo-augmented. Cool. a geo-augmented prompt back to the user. So this is the Selector Copilot. I've zoomed in heavily so everyone can see this. How to use the tool, some warning that no data or any of this stuff is retained or stored. We do some logging, and that's about it, but we do not track anything about the user. You don't even have to sign in. We have some sample packets, and I'm going to use this single packet capture. And let's quickly look at that single packet capture in Wireshark, just to show you what we're dealing with. Now this, I would argue, is almost antiquated. This is the old way. Source, destination, UDP, and then all the payloads and all the information in Wireshark, right? So even a single packet has all of this to consume. What I would suggest is that with the Copilot, we can upload that same capture and ask questions about it. So let's just simply at a very high level say, what can you tell me about this packet capture? Send. It's actually going to go ahead and fetch the geolocation details before answering because it has detected the presence of a public IP address. Now this might feel long. It is going to take a few seconds because we are using a reasoning capable model that presently runs a little bit slower, theoretically, than a chain of thought model. However, we're going to rely on the deeper insights, the deeper reasoning, the deeper inference using the more current reasoning models. So that's not too bad. We're going to trade off a little bit of performance for quality. So now let's check this out. What can you tell me about this packet capture? It has the timestamp, frame length, captured protocols, Ethernet layer, even doing the Mac OUI lookup. So we know who made these NICs, the MAC addresses, based on the OUIs. Very cool. And then at layer 3, we have the source, which is private. Now check this out. Check out the metadata enhancement. The geo-augmentation, let's say. Destination IP, which is public, but that is located in San Jose, North San Jose, California, US. So now not only do we have source and destination IP and protocol and TTL, we actually know the location of where this packet is going geographically. And then we have the UDP layer, layer 4 information, some observation and notes. And it even says here, overall, this capture shows a straightforward UDP transmission from a local Intel-based device to a public IP address in California. Pretty cool, right? Pretty cool. And then there is that geo stamp again at the bottom, just to give you the geo-enhanced data. So let's refresh this page. And what we're going to do is, we're going to upload one that is a slammer worm. So this one here is called Slammer, and this is a dangerous packet. It has 2 public IPs and a remote procedure call protocol, right? And it actually is malicious traffic. I use this as an example of a security flow that the Packet Copilot can do. So let's do Slammer. And then let's say something like, we're going to lead the witness a little. We're in security and we understand that there's an attack and we're trying to glean information, right? So based on the provided packet capture, where is the attack originating from and targeting? What can you tell me about this malicious traffic, including points of origins? Okay, so just a little more fun prompt here. Based on the provided packet capture, where is the attack originating from and targeting? And what can you tell me about this malicious traffic, including points of origin? Maybe we're doing a retrospective from an attack, and we're trying to find out where the attack originated from in the world and what it was targeting in the world, geographically, not just from an IP point of view. So it is going to fetch the geolocation details again. And this prompt might take 3 to 5 seconds longer because of the complexity of the prompt and because of the, again, that reasoning capability that I've been speaking about. But again, this is all agentic. In case you're wondering, and let's do something while that runs in the background. I'm going to show you partially what this agent looks like, the interesting portions. So we're going to have a prompt, and the prompt tells it has access to this fetch IP tool that retrieves geolocation. We give it an example which follows the REACT process: question, thought, action, action input, observation, and final answer. Right? Where is the IP located? I need to look up this IP. I'm going to use that tool. The input is going to be the IP address. My observation is going to be the geolocation information, and I'm going to give the user a final answer. All right, we then create this React tool, including our large language model, our tools, and our prompt, including the tool names and descriptions as a partial, and an agent executor to finally execute this agent that we've just built. That's really all that goes into it, less than 150 lines of code. So here we go. Attack origin and target. Origin IP was from Pozuelo de Arlanzón, Madrid, Spain, in Spain. And the destination IP was in Pine Grove, California. So now we've layered over this metadata on top of this malicious packet to actually know where this traffic is going. Right? So the source is sending traffic to that IP over UDP port, commonly associated with the SQL browser service. Some key observations, right? Slammer worm. Here's the MAC addresses, and here is the RPC, which can hint at older base services being targeted. Malicious actors sometimes craft packets to attempt remote code execution or to leverage known vulnerabilities in the Windows RPC services. We have the indicators and the traffic from Spain contacting a US-based address, right? And then it mentions California in here again and Spain in here again. So we've overlaid this rich geolocation information into an already astonishing capability in the Packet Copilot. So I urge you to play with this and to check this out. And again, I also urge you to look into the AI Agentic approach, which Selector and myself have been putting out quite a bit of material. So where can you find this? I want you to visit packetcopilot.selector.ai. If you need packets to play with, we have samples here that you can just download right in your browser and start playing with them. On any platform, on any browser, it's all hosted in the cloud. It's totally free and totally anonymous. So I want to thank you for joining me today, and let's celebrate this new metadata of geolocation information tied to our packet capture analysis. Thank you.